In this video, I will try to design the Planet Zombie from scratch. In here, I will use the principle composition over inheritance. So, instead of a big and complex inheritance tree, I will divide the plants and the zombie into multiple behavior, then combine it together. Let's go straight to the fun part. First of all, let's talk about each of the characters. So, the paint shooter is gonna shoot the zombie. The sunflowers is gonna give you resources, the suns. And the zombie, we gonna have the baby zombie, which gonna go and eat your plant. In the scope of these videos, I will talk only 3 of the character. The leftover characters will be talked about the upcoming videos of the series. So, we know that all the characters right here, they can take damage, which means they have health. The plants, especially pea shooter, can deal damage to the zombie, and the zombie can also deal damage to the plant. However, they will also have their own behavior. For example, the plant, especially sunflower, can give sun. That is only the sunflower have. The pea shooter can shoot projectile. And the zombie can move. We're gonna list all the behaviors of this character. The zombie also can eat plant. Am I missing something? Oh, I almost forgot. This character, they can die, right? They can live or die. So, they all gonna share this. Remember when I talk about the pea shooter can also damage the zombie? However, what pea shooter does is gonna shoot the projectile. And what dealing the damage to the zombies is gonna be the P, which is the projectile of the zombie. I have the P right here. It can also live or die. And it can move like a zombie. Also, it can damage the zombie, so I will change this to can damage. Can deal damage. In each character, now let's call it entity. In each entity, we gonna use each behavior that belongs to that entity only. So, if the sunflower can shoot the projectile or can move, we will forget about it. The only thing about the sunflower we will know is they can give sun, it can take damage, and it can either live or die. And we're gonna have much more behavior. So, for example, the pea shooter, we're gonna have it, the ability to detect the enemy. We also not to forget the collision detection. So the pea shooter gonna know if we have the zombie that's coming from that lane, and also we gonna check if the pea gonna collide with the zombie. Oops. The zombie also have ability to collide with the plant. Now, let's talk more about the zombie. Do you remember the behavior of a zombie that they're gonna stop once they found the plant that's in front of him, and they're gonna eat them. So, we're gonna divide it into 3 sections. Let's call it eat behavior. That is after collide with plants, the zombie will stop moving and start their damage. And if the plant is dead, continue moving. So this behavior is exclusively to the zombie only. To enable this behavior, we gonna have the dependency onto so many things, which is the collision detection to check if we are collide with the plants. We're gonna use the moving behavior to stop moving the zombie, the DN damage to start DN damage, and we're gonna check if the plant is dead or not. If it is, we're gonna use the move behavior again and continue moving our zombie. Now, let's design the database. Alright, let us continue. The first thing we're gonna have is the entity table. In here, I will list all 3 entities. Let's call it ID and name. Paste right here. I almost forgot the zombie. Sunflower, pea shooter, basic zombie, P. Next step, what I'm going to do is to create an health or can take damage. I will call it damageable behavior table. So let's try to do what? You know what? I will copy all this to here and change the name to damageable behavior. The ID, I will turn it to entity ID. Just like that. And here, it will have the health. So, I will store the data about the damageable. So, for example, these sunflowers had the health of 60. Same with the pea shooter. And same with the basic zombie. And the P, which doesn't have the damageable behavior, and delete it. So, as you can see, the P didn't care about the damageable behavior because it didn't have it. Only those entities care about it. Next up is can give sons. So I'll call it resource giver behavior. This time, the only count is the sunflower and it has resource amount. Let's go shorted amount. You know that the sunflower can give like 1 suns at a time. And we're gonna also have the recharge time. Like how many seconds did it take for the sunflower to generate 1 suns? I'll say 3 seconds, I don't know. So we finished. The pea shooter and the zombie we didn't care about giving resource anything. Only the sunflower care for it. Next up is can shoot projectile. This behavior is exclusively to the pea shooter. We're gonna change it to the pea shooter. In here, I'll have the projectile ID, which, as you can see in the entity table, which had the P. So the pea shooter can choose P. In the future, if we want to change how pea shooter gonna work, we just gonna change the ID. That's all. So the pea shooter gonna shoot the P, and I will change it to 4. And in the shooting behavior, we're gonna have the shoot interval, like the time between each shoot. So I will call it like the same 3 seconds. Let's put the S right here for differentiation. You see that because its behavior is exclusive to the pea shooter, the sunflower and the zombie didn't care about it. It wouldn't know it at all. So it would not have the abundant fields like project ID or shootable time. It has their own fields like the sunflower is gonna have the shot time and the amounts of resources. Now, let's talk about the mobility behavior. This behavior indicates which entity can move. As we discussed earlier, the entity that can move is the zombie and the P. Similar to the projectile, we're gonna change the field. In here, we will need the movement speed, the direction. So, for example, the zombie is gonna move from right to left and the P gonna move from left to right. Let's change the speed. In here, it will be like 4 seconds, like, I don't know, 4 miles per second. It will depend on you. And the direction is gonna be right to left. It will be the enum field. This time gonna be left to right. If you guys enjoyed this video so far, please give this video a thumbs up and subscribe to the channel. It will help to bring this video to more others. Let's continue. Both zombie and P also share a common behavior, that they can deal damage. Let's call it damage behavior. In here, instead of movement speed, we call it damage, and there's no longer need for direction. So for example, the zombie can deal 4 damage to a plant per second, and the P can deal 5 damage to a zombie per second. So let's see what we have left. We're gonna have the collider behavior or collision. So this behavior will allow the zombies and the P. I think I will copy this for saving time. Let's leave the column empty so we can fill it later. In here, we will check if the zombie or the P this collide with other entities. And last but not least, we're gonna have to detect enemy behavior. So for example, the pea shooter can detect the enemy from that lane. Did you know we also have the eat behavior for the zombie? Let's make a table of that. In here, I'll put the eating behavior. And we're gonna leave the zombies only. So, to implement this, we're gonna check if the zombies has been collided with some kind of plant, and if it does, it will start eating, which means it will start dealing damage. But while dealing damage, the zombie must stay still. That's all the data about the current behavior. You can use this data and ask AI to build the system for you. But now, let's see my implementation for this. So how do we implement this? At the first of the game, we will get 3 cards of plants, right? So we can represent this as an array like this. We call it in-game entity. It's gonna be an array which contains the ID of the plant. Let's call it. So we have the in-game entities, and we also have a bunch of behavioral table like damageable, movable, something like that. So each time we buy a plant, let's see, we buy pea shooter, we gonna loop through all the table, and then we gonna check if each of the item in the table contain the config ID of the pea shooter. If it is, we gonna add those behavior to the pea shooter. So for example, the pea shooter gonna have the ability to shoot projectile and can be damaged. So I only add the damageable behavior and the shoot projectile behavior to the pea shooter. I'm not gonna care about the movable or can give suns wherever. Just like that, the pea shooter can no longer need all the behavior except what it needs. You don't need a big inheritance tree. You just need what the pea shooter needs. First of all, I will have the interface behavior data, which has only the entity config ID. So each behavioral table will all gonna share this. Next up is the interface behavior, which contains the entity and the ability to add itself to an entity. We will also have the generic type version of it, which the T data is actually derived from I behavior data, and it had the method of initialize contain T data. But what if we want to inject all the system into our behavior? To do that, I use an interface called iBehavior template, which also have the ability to generate behavior based on the data. So, if we want to add other dependency to the behavior, for example, the mobility behavior, need time system to do so to update the position, something like that. We will inject the time system right here. And lastly, I will have the behavior views, which also have the generic type of T behavior. And because I'm using unity, we're gonna derive from mono behavior. Next up, I will show you how I implement the iBehavior package. First of all, I will implement the dimensional behavior data. If you can recall from those tables, we're gonna have an entity config ID and an help. This is all the values that we can config to our entity. Next up, we're gonna have a damageable behavior which implement the iBehavior interface. And for the generic type, we're gonna have the damageable behavior data. We're gonna have the current logic here, like current health mark health, the data, the game entity. We're gonna have a property so that we can retrieve it from other classes, and the events on damage taken, so we can like update an UI or something like that. In the initialize method, we're gonna add those fields from the data to our behavior. And we're gonna also have the class add the entity, which has a similar logic, like entity can add behavior from it. Next up is a specific method, take damage. That belongs to the damageable itself. You see, the whole point of the damageable behavior is gonna check that is this game entity can take damage. So if it does, we gonna minus the current health for the damage and invoke the event. And if the current health is less than 0, we're gonna kill the entity. And finally, we're gonna have the damageable behavior template, which implement the iBehavior template, damageable behavior, and damageable behavior data at a generate type. The generate behavior method of this class is going to be simple because we're not going to have any kind of dependency. However, if we did in the future, for example, like a modifier, so we can take less damage or more damage, for example, we can also add that dependency like that system right here. And when we initializing a new behavior, we're gonna add those dependency to it. Another example I'm gonna show you is the damage behavior data. So on the contrary, instead of health, it will have the damage. And for the damage behavior, it's all gonna be the same. We're gonna have the flows of the damage, the data, the game entity, and so on. And the specific method of this class is deal damage. We're gonna check if other entity has the damageable behavior. If it is, we're gonna deal damage to it. And finally, the template for it. We're gonna create a new damage behavior template, implementing the iBehavior template, which has a damage behavior and damage behavior data. Let's distinguish between the damageable, which indicates that this entity can take damage, and damage, which that this entity can deal damage. And from a generate behavior, we're gonna create a new damage behavior. Now, let's make the behavior provider. First, I'm gonna create an interface iBehavior provider, which has two methods, setup config and by behaviors, which has the parameter of an array of game entity. Next up, we're gonna implement it. I'm gonna use generate type for it for code reuse. In here, I will have a dictionary of behavioral data, which contain the key as an ID and the values of the behavioral data. Next up, we also set the config data and the behavioral template. We're gonna talk about the behavioral template later. In the setup config method, What we're gonna do is we're gonna clear the behavior data dictionary first, then we're gonna add to it. In by behavior method, what we're gonna do is we're gonna loop through all the current entities and try out if we had the config ID of that entity belong to this behavioral data provider. If it does, what we're gonna do is we're gonna create a behavior from a template from it. Remember those part. This is the part where we can add another dependency to it. We're gonna call behavior that initialize using behavior data, and we're gonna add to the entity. In the game entity view, it's all gonna simple. We're gonna need an instant ID side by side the config ID, because although the config ID can be the same, however, if we have multiple entity like multiple basic zombie at the same time, we're gonna need an instant ID to extinguish those zombies. Next up, we're gonna need a name. This is very simple, just name it sunflowers or pea shooter or basic zombie. If we have more complex problem in the future, we're gonna refactor it. Next up, what we're gonna have is the it exists field to indicate if this entity exists, like if it's dead, like basic zombie can be dead or a plant can be dead or cannot be initialized. We also have a type, just name it here, like for example zombie or plants, and we're gonna have the is enemy boolean to indicate that it is the enemy or not. Now let's move to the important part. Is it a behavior dictionary? What we're gonna do is we're gonna ask the behaviors to this entity. When we have an entity table, this table is very simple. All the complex logic have been moved to behavior instead of prolong those class in the game entity itself. We're gonna have three methods for it. First of all is add behavior. To add this to the game entity, we're gonna have the method to check if this entity has a certain kind of behavior. And finally, we're gonna retrieve behavior out of it. You can see that most of those codes is not entity related. So if you want to like change your engine to growth or something like that, you can just move through those things and not really care about what entity does. Now let's see how we're gonna bind those class together to make the package more coherent. First of all, we're gonna have an array of inactive entities. We have sunflower, pea shooter, basic zombie, and 2p. You see that we will have a different instant ID for those 2p, but they all gonna share the same config ID. The config ID will indicate that the p gonna use some behavior, but the instant ID gonna distinguish that if those p are different or not. Next up, we're gonna initialize undamageable data. We're gonna have the sunflower, the pea shooter, and the basic zombie. Similarly, with the damage data, we're gonna have the basic zombie and the pea. The mobility data, we're gonna also have the zombie and the pea. In the shoot projectile data, we're gonna have the pea shooter only. And the eating data, which only belong to the basic zombie. About the enemy detection data, we're gonna bind it to the pea shooter because the pea shooter is needed to detect when a zombie is appearing. Next up, remember that I talked about how the behavioral template works. It's gonna be a medium so that we can bind the external system to our behavior. For example, in here we have the update system and the spawn entity system. And when we initialize those templates, you will see that in the mobility behavior, we're gonna have the dependency of the update system, and we're gonna pass this to our behavior itself. And in the shoot projectile behavior, we're gonna need to spawn those p so that the pea shooter can shoot them. So that we're gonna need a spawn entity system to do so. Next up, we're gonna initialize those behavior provider using the template, behavior, and behavior data. We're gonna have the damageable behavior provider, the damage behavior provider, the mobility behavior provider. the shoot projectile behavior provider, the eating behavior provider, and the enemy detection behavior provider. We're gonna add those to a provider list. And then for each provider in the provider list, we're gonna set up the config and we're gonna bind those behavior to an active entity. In here, I will run this example in Unity, and I has already made a simple edit tool to preview this. You see, we'll have the entity behavior view here. The sunflower will have an instant ID and a config ID, which all one, and it's gonna have a damageable, which contain unhealth. The pea shooter also have the damageable, but it has the shoot projectile and an enemy detection. The push projectile. The shoot projectile will have the projectile ID and the shoot interval. The basic zombie also have a damageable property. It will have a damage which is 4.5. The mobility, which indicates that the zombie can move from left to right, will have the movement speed of 4.5 and the eating interval for it. And finally, those P gonna also have damage and mobility itself. You will see each entity has its own collection of behavior and it did not have those that it did not need. For example, the P will not be damaged, so it would not have it. And the basic zombie can shoot anything, so they will not have the shooting behavior.